Assalamualaikum warahmatullahi wabarakatuh. We are from Group 2A. There are four types of microsystem packaging, which are microelectronic, RF and wires, photonic and MEMS. But today we are going to present about microelectronics. Okay, there are four table contents, which are introduction, background history, application and future trends. So we are going to start with introduction from Fikradi.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fikri Adik bin Raja Ali. My number matric is 2020100630. So now I would like to present about introduction of microelectronic. So what is microelectronic? Microelectronic is defined as the area of technology associated with and applied to the realization of electronic system that made of extremely small electronic parts or elements. The term microelectronic is normally associated with integrated circuit IC, as the name suggests is related to the study and manufacturing, fabrication of very small electronic design and components. These devices are made of semiconductor materials. Microelectronics include active transistor and diodes and passive RLC components. Microelectronic is based on transistor-dominant device that fabricated at submicron dimension as integrated circuits or IC and measured in micrometer scale. Microelectronic is becoming the significant nerve of the modern world. It has touched every aspect of modern life. One cannot imagine a world without personal computers such as cell phone, fax machine, camcorder, stereo players, television, microwave ovens, calculator and others. So that's all from me. Thank you.
Hi, my name is Hanan. Today I'm going to present about history of microelectronics. The most fundamental building block of microelectronics, the transistor, was invented by William, John and Walter on 1947. Because of their achievement, they awarded with the Nobel Prize for the invention of transistor. The structure of transistor is the first form of the transistor and was made from gold foil strips pressed into contact with a slab of germanium on a plastic triangle. It is the size of a thumb, which is much larger than the modern microscopic transistor. Baden Britten and Shockley connected a microphone to one end of the unit and a loudspeaker on the other to test amplification. The man took turns picking up the microphone and whisper, "Ring, hello," yelled the loudspeaker on the other end of the line. This moment is significant to microelectronics because it's followed by a technology revolution throughout the world. The progress in microelectronics has been focused on shrinking the circuitry embedded onto chips. So a decade later, Jack Kilby invented the integrated circuit, which is IC, a small circuit containing electronic components, including transistor, resistor, capacitors, and other components. Kilby worked for Texas Instruments, a semiconductor manufacturer, as an electrical engineer. Since each component had to be wired to any other component, he has irritated by the limited technical advancements because of the wires. The number of components used in device was limited and sensitive to damage. Kilby construct a circuit entirely out of semiconductors using Texas Instruments, knowledge of semiconductor using knowledge of silicon transistor and semiconductors, So Kilby's final product, the integrated circuit, which is IC, eliminated the need to wire each part individually. It was much smaller than other previously devised circuit.
Gordon Moore, which is one of the Intel's co-founder, published an article in Electronic Magazine about the future of microelectronics in 1965. Moore predicted that as transistors advance, the computational capability of integrated circuit will increase exponentially, while the cost would fall exponentially. Transistor dropped substantially in size, while the number of transistors utilized in circuits increased dramatically. Moore's observation garnered a lot of attention and became known as Moore's Law in the scientific community. Moore's Law continues to accurately anticipate the future of microelectronics. Okay, then Intel built and released their first microprocessor, which is the 4004 chip in 1971. That microprocessor was constructed with 2,300 transistors that giving them the same computing capacity as the room-filling ENIAC. Intel continues to create microprocessors with increased computing capability, which are still used in most desktop computers today. From phones to drones, technological innovation is at all-time high. Microelectronics has played a significant role in humanity technological progress in the past and continues to do so today. Nanotechnology is predicted to be the microelectronics industry in the future, which is significantly smaller components processing at much quicker speeds.
Next, the application of the first technology wave, microelectronics, which is RFID. RFID stands for Radio Frequency Identification. It is a wireless technology that uses a cheap electromagnetic frequency to identify something. RFID systems are used in most passports, vehicles, contactless card payments, smartphones, key fob, and more. An RFID system consists of a transponder, which is a tag, and a reader. RFID readers are made up of a radio frequency module, a control unit, and an antenna that generated an electromagnetic field. On the other hand, a tag consists of a single antenna for receiving and transmitting signals, and an integrated circuit, which is IC, that stores and processes data while controlling and decoding radio frequency, which is RF, signals from the antenna. An interaction happens between a tag and a reader when they are close enough to share an electromagnetic field. This interaction ignites voltage in the tag's antenna to power up the tag's microchip. The microchip then receives power and data of request from the reader and returns the requested data to the reader. Since World War II, RFID technology has been a long-standing technology used to identify approaching friendly aircraft and enemy aircraft by the British military. The manufacturing of RFID chips has expanded in the last 2 decades. RFID technology has also enabled state-of-the-art techniques and advances in microelectronics health monitoring through contactless testing. Their use spread very quickly among many industries, from healthcare to wear stores.
We move to future trend on microelectronics. Looking back on the 20th century to today, the computer chips literally transformed the way we live, work, and travel. This chip can be found in everything from our nation's most powerful supercomputers to our cars and household devices. But now, our microelectronics need to be revamped for another transformation to process far more data and serve more functions while using less power. Microelectronics must be integrated with other new technologies to equip the computer chip for the next generation. The scientists are combined ideas from nanoscience, neuroscience, quantum science, and a range of other fields. For example, in scope of medical field, They can use nano chip to heal organ at a touch. In terms of medicine, scientists call that as nanotransfection, which is this technology can transform skin cells into stem cells to repair any types of tissues. In details, injured tissues can be repaired and damaged organ also heal using a nanotouch device that adapts a patient's own skin to generate stem cells. Tissue nanotransfection, which is basically a lab on a chip, can adapt skin cells to change into any type of tissue required, which can be introduced to injured or degenerate areas. It was claimed as a success rate of 98%. We can convert skin cell into elements of any organ with just one touch. The process only takes less than a second and in non-invasive. The most important is the chip does not stay with you and the reprogramming of the cell starts. This technology also keeps the cell in the body under immune surveillance, so the immune suppression is not necessary.